So we are talking about bubble sort. So sorting means arranging an unordered collection of elements into an ordered one. Something like this. You have elements of the array in some random order. You are arranging them in increasing order. This is sorting. So the technique which we are going to use is bubble sort. Why is this name bubble given up? Why is it called as bubble sort? Okay, one example I will try to give you about the bubble sort. If you general example, if you see you have a water can, okay, and there is some container here like this, which has a tap, okay, which has a tap here. I think you might have seen some containers like this, both plastic one. This is one 20-liter can, and it is inverted inside this plastic tub, which has a tap, right? So in this case, you try to you observe when you fill your bottle, you will see that some air bubbles are going up. You will observe some bubbles. Okay, right? Water going up always, and some air is going up, and you are facing some bubbles there, right? So when you see these bubbles going up, this time when you see this kind of situation, if you capture that in slow motion, if you see that, you will observe that the largest bubble is going up. Small bubble, small, the bubble is becoming big here, right? It is called bubbling up, means sending the largest one to the upwards, okay. That's why the name has come as bubble sort. We say it is bubbling the largest element, okay. Bubbling up the largest element is bubble sort, right? So what is the logic here? Move from the front to the end, bubble the largest value to the end by using pairwise comparisons and swappings. Okay, let's see the case how we try to do for this example. See, first I have to compare these two elements. 42 and 77, right? After I compare these two, which one is, check whether this is big or this is big. They both are in nice location. 42 is in small one, 72 is large. So I will not change the order. Next, what I have to do, I have to compare these two elements, 77 and 35. So next we will compare 77 and 35. After comparing, I am swapping it. We are doing swapping here. Okay, we are doing swapping here. So 35 and 77. Next, you have to compare 77 and 12. When you do, yes, this is great and this is less. So you have to swap them. So again, I will swap 12 and 77. Next, you will do 77 with 101. This is small, this is high. There will not be any change.
Sir,
Change.
your voice is lagging.
Okay. Right. Now am I audible? Is it clear? Am I audible now? Is it clear?
Yes, sir.
Yes. Okay. Thank you. So in this case, we are trying to compare 77 and 101. When you compare 77 and 101, there is no requirement for swapping because this is small and this is big. So we will not try to swap it. Then no swap needed here. Then I will compare these two, 101 and 5. Right? Definitely we have to swap it. So this becomes 5101. Okay. So if you observe, after the first iteration, we have pushed the largest element to the end. Wherever it was, it came to the end. That's why bubbling up the largest element, right? Like the water bubble goes up with the air, it goes up and it opens and breaks there, right? The largest bubbles goes out on the top. Okay, that's why we say this. So with this, we try to fix the location. It has come in its own original place. Okay, next what I have to do, again begin from the starting. Again from here, once it is done, again you move the control to the beginning place. This time you don't compare, you don't go till n, you come only till this 5 only. We are reducing one element size here. We will not go to that location. See, I will come back to this. So the logic is very simple here. Index is 1 and the last compare it n minus 1, that is n minus 1. So if index is greater than the last compare 1, then you will check this. If a of index greater than a of a plus 1, then swap. Otherwise, just increment the index. Okay, let's not make it no simple. We will see that code and try to understand about bubble sort. So how it is happening? Bubble sort, we will compare a of I and a of I plus 1. If a of I is greater than a of I plus 1, that is a of 0 greater than a of 1, a of 1 greater than a of 2, a of 2 greater than a of 3, that way. Then you will do swapping a of I and a of I plus 1 both. In that it will swap it. Okay, so this way. Now when we have n elements, we repeat the process n minus 1 times. We repeat the process n minus 1 times. Okay, why we have to do? If you observe, if you take a small example and try to see how this is working, let's take 5, 2, 3, 1, 4. This is the array which I have. So in the first iteration, I will compare these two. It becomes 2, 5. Then again I will compare. This is normal. Then I'll compare these two. So it is 2, 3, 5, 1, 4. So see, here a swap is happening. Here a swap is happening. Then I'll compare these two. So there is one swap. It becomes 2, 3, 1, 5, 4. Then I'll again compare these two. One swap will happen. It becomes 2, 3, 1, 4, 5. So this is your iteration 1. And how many swappings you have done here? Total 4 swappings. Then again you have this as the array. We will ignore this. Again we'll start from here. We'll compare these two. Anything required? No. Compare next these two. 3 and 1. Yes, we have to do a swapping. So it is 2, 1, 3, 4 and 5. Again 3 and 4 not required. Don't go to 5. This iteration is over. Second iteration. Okay. So 4 has come in its own place. Then again take 2, 1, 3, 4, 5. Compare these two. Yes, there is a swap required. It becomes 1, 2, 3, 4, 5. Then again compare these two. No required. It is order. So this is also gone. This is your third iteration. Then you have to also apply fourth iteration. Comparing only 1 and 2. They both are in same place. Over. So like this you have to repeat this. When there are n elements are 5, you have to do it n minus 1 time. And I am talking about some very important MCQ based question, right? What is this MCQ based question here? One thing I told, after 2 iterations, what is the state of the array? This is the state of the array after 2 iterations. The next question, which is very popularly being asked in exams, is that how many swappings have you done? Number of swappings required to sort this given array using a sorting technique, like bubble sort. The question is, maybe using bubble sort, how many number of swappings are required to sort this given array using bubble sort? If you count here, 1, 2, 3, 4, then 5, then 1, 6. So only with the 6 swappings, we are able to convert this array into a sorted order. Okay, that is one very important question, right? So please practice this kind of things. In internet, lot of questions are available of this model, right? So this is about the bubble sort, how it works. That's what, n minus 1 times. See, first time 101 reaches here, then second time the second largest comes here, third time it comes here, fourth time the fourth largest. So our focus area is reducing, you see. Like our focus area was reducing in binary search. Same thing, my array length is decreasing from n minus 1, n minus 2, n minus 3, n minus 4 and so on. This area where I am focusing is reducing. Okay, so that's it about this bubble sort. This is the final code what we have, but I think I have this code with me, just a second. Again, this is an example. So how do you avoid this? I'll just go back there. This is again same example explaining step by step how we do it. Right. So how is this bubble sort working? You see, you are iterating from 0 to n minus 2. Why are you going to n minus 2? Because in the array, you have 10, sorry, 8, 6, 1, 4, 3. I have this as the array. See, when I'm comparing, I'm doing this 2, then I'm comparing this 2, then I'm comparing this 2, then I'm doing this 2, then I'm doing this 2 here. So, what is my condition here? A of I greater than A of I plus 1, I'm saying. If I go till n minus 1, it will do this 3 and this location also. That's why we have to reduce it to n minus 2 so that it stops here. This becomes your I, this becomes your I plus 1. And you are comparing 4 and 3. That's why you have to go till n minus 2. Next, second one, J0, J less than n minus 2 minus I. What is this n minus 2 minus I? I will teach you one technique, how are we writing this n minus 2 minus I after this bubble sort is over. You will understand it much better. Why are we writing this? So, one shortcut technique. So, n minus 2 minus I, because you see, if you go to this example, just a second. See this example. See, when I value is 0, I am iterating from 0th index to n minus 1. I am going till here, I am comparing till here. When I value is 1, I am iterating from 0 to n minus 2. When it is 2, I am going from 0 to n minus 3. When it is 3, I am going from 0 to n minus 4 only. So, what is happening actually? We are trying to add this, we are trying to subtract this value here. This 1 I am trying to subtract. N minus 1, minus 1 if I do, it becomes minus 2. This 2, n minus 1, minus 2 if I do, it becomes n minus 3. That's why n minus 2 minus I. Based on this I am reducing the number of locations which I have to compare. Okay, that's why we are saying, we are talking about the there we are talking about this I case, right? N minus 2 minus I. Then simple A of j greater than A of j minus 1 or A of j greater than A of j plus 1, that whatever you take, you just swap the elements. Okay, so this is the logic of bubble sort technique, right? So time complexity, when it comes to time complexity of bubble sort, best case, worst case, average case, if you let us try to analyze that. Okay, let's try to understand the best case, average case and the worst case of bubble sort. See, your technique is to compare every two elements. The logic here is to compare every two elements in each iteration. Like this you do. Again, in second iteration, you are comparing 3 times. Again, other iteration, you are comparing 2 times. Last iteration, you are comparing 2. See, you are comparing every time. Even if you are giving sorted array, even if the input is sorted array, right, you have to perform the iterations n minus 1 times and you have to do these comparisons. Because the computer does not know, the program does not know that this is already in sorted array. It will simply check this 2 not required, check this 2 not required, check this 2 not required, this 2 not required, this 2 not required. Okay, come back. Next, reduce the size, check only first 5 elements. Again, it will verify this 2, because it does not know. A same program may take this input or the reverse input. Okay, so even for the best case, it is running through the whole logic, right? So in best case also, it is running over this 2 for loops, that is order of n square. It is going over 2 for loops. Worst case, you see, worst case also same, it has to go through the complete logic. So here also it is order of n square. Same way for average case as well. So all these 3 best, worst, average cases for bubble sort is order of n square. Why? Whether it is sorted or not sorted, it has to, the algorithm will run there is no way to reduce the no iterations. There is no check in this algorithm. We have no strategy to avoid doing iterations if the elements are already in sorted order. It will keep verifying it. That's why the best, worst, and average cases, it is order of n square. Right? This is about the bubble sort technique.